Question 15. Part A, express 2 cos theta minus sin theta in the form of r cos theta plus alpha, where r is more than 0 and alpha is between 0 and pi over 2. And then give the exact value of r and the value of alpha in radian to 3 decimal places. Okay, so just change that into the harmonic form. So we have 2 cos theta minus sin theta. And they want us to write in the form r cos theta plus alpha. So we just let equal to r cos theta plus alpha. And then do the expansion. So r cos theta cos alpha minus r sin theta sin alpha. Use addition formula. And then 2 cos theta minus sin theta doesn't change. So now you just have to compare the coefficients. So for cos theta, the coefficient is 2. And then for the second half, the coefficient of cos theta is r cos alpha. And then for the second one, the coefficient is just like it's sin theta is 1. Yeah. And then the other one will be r sin alpha. So therefore, we have r sin alpha equal to 1, and then r cos alpha equal to 2. So therefore, tan alpha equal to 1 over 2. So alpha is just tan inverse of 1 over 2, which is 0.464 radian. And then to find the exact value of r, so if you know how to do it, you can just use the Pythagoras, like the square root of 2 square plus -1 square, which is just root 5. And if you want to know how to get that, so I can show you as well. So, but like you don't need to do that in the exam. You can just use r equal to square root of the coefficient squares at each other, and that'll be the answer. Yeah. But if you really want to know why, you can square each one. So r square sin square alpha plus r square cos square alpha, that's equal to 1 square plus 2 square. And then for this one, if you factorize the r square, you will have sin square alpha plus cos square alpha, which it just cancels out, become 1. So you have r square equal to 1 square plus 2 square. That's why if you square root it, you will get exactly the same thing, root 5. So that's why in the exam, you don't have to show all this because it's only 3 marks question. So you can just use square root of 2 square plus -1 square or just 1 square because, you know, it's squared. It doesn't matter if it's -1 or 1. It will get the same result, equal to root 5. And then part B. So figure 6 shows the cross-section of a water wheel. The wheel is free to rotate about a fixed axis through point C. So that would be the center. The point P is at the end of one of the paddles of the wheel, as shown in figure 6. The water level is assumed to be horizontal and of constant height. So that's the water level. And then the vertical height, h meters, of P above the water level. So h just means the height above the water level is modeled by this equation where t is the time in seconds. And then using the model, find the maximum height of P above the water level. Okay, so first we need to use part A to rewrite this equation in the easier form. So h is 3 plus 4 cos 0.5 t minus 2 sine 0.5 t. And then 3 doesn't change. We can factorize out 2. So that would be 2 cos 0.5 t minus sine 0.5 t. And then 3 plus 2 doesn't change. And what's inside, you can see is very similar to this. So you have 2 cos, this is 2 cos, and minus sine here. It's just instead of theta, this is 0.5 t. So to replace it, you can change that into cos of, actually I forgot to write the final answer for part A. So r is root 5, so it's root 5 of cos theta plus 0.464 for part A. And then if we use that form, so it should be the same, root 5 cos, instead of theta, this is 0.5 t, and then plus 0.464. So expand it out, that would be 3 plus 2 root 5 cos 0.5 t plus 0.464. So that means the maximum height has to be 3 plus 2 root 5. And then BII, find the value of t when this maximum height first occurs. Keep your answer to 1 decimal place. So we want to work out the value of t when the maximum height first occurs. So the maximum height only occurs when cos is equal to 1. Then we can get 3 plus 2, 5. So we just solve that equation. Cos 0.5t plus 0.464 equal to 1. So then 0.5t plus 0.464 is equal to cos inverse of 1 is either 0 or 2 pi. And then so on and so forth. Yeah, like that won't be like 4 pi, 6 pi. But we're looking for the maximum height first occurs. So first, t cannot be negative, ignore this one. So this would be the first positive value. So ignore the rest. We only need to solve this. So t is equal to 2 pi minus 0.464 and then divide by 0.5. That would be 11.6 seconds. That's it. Okay, next part. In a single revolution of the wheel, P is below the water level for a total of t seconds. So according to the model C, find the value of t, giving you answer to 3 significant figures. So it says in a single revolution of the wheel, P is below the water level for a total of t seconds. And we want to find that time below the water level. So because h meters is the height above the water level. So if it's below the water level, then the height has to be less than 0. So we just work out at what time the height is equal to 0, which is just on the water level. So then 3 plus 2 root 5 cos 0.5 t plus 0.464 equal to 0. So then rearrange that. Cos 0.5 t plus 0.464 is equal to minus 3 for both sides and divide by 2 root 5. So then we get this. So 0.5 t plus 0.464 is equal to, so cos inverse of negative 3 over 2 root 5. That would be 2.306. And the other one would be negative 2.306. And then since we're looking for the positive values, so this is the first positive value, and then this one is clearly negative. But if we're plus 2 pi, that will give us another positive value. So if we're plus 2 pi, then we have 3.977. And then this one plus 2 pi, that will give us another one. But we don't need that many values. So we only need the first 2 positive values. Yeah, so we ignore this one and just work out those 2. So then once we solve that, T1 is equal to 2.306 minus 0.464, and then divide by 0.5. That is equal to 3.684. And then T2 is equal to 3.977 minus 0.464, and then divide by 0.5. So that would be 7.026. So what's that mean is, so because the wheel is rotated, and then 3.684 is the first time like reach the water level. So that would be 3.684. So like it goes something like this. So it's the first time reach the water level and then continue to rotate. And then the second time reach the water level, that would be 7.026. So if we're looking for the total time below the water level, it has to be the bigger one minus small one. Then we can work out the time taken below the water level. So what I'm going to do is just use the first one, 7.026 minus 3.684 to get the final answer. So minus them, I will have 3.346 they want 3 significant figures, just 3.34 seconds. So that would be the final answer. And then part D, in reality, the water level may not be of constant height. D, explain how the equation of the model should be refined to take this into account. So they don't want the water level to be constant height. So that means like this is a constant. So if you don't want that to be a constant height, you need to make that vary. You can't make that constant. So you can just say 3 would need to be vary. So meaning it just we can replace 3 into a periodic function. For example, like into a trig, something like sine something or cos something. But that's all you have to write. Yeah. So 3 need to be varied. It's only 1 mark. All right, that would be all the solutions.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.